Here we have homework number 9, question number 6. And to solve this equation, we need to recognize that it is a non-homogeneous higher order with constant coefficients differential equation. This means that we can use our Jafar method. And to do so, we are going to turn this into a derivative function, annihilator-esque kind of function, basically turning it into terms of d. And doing that, we get d squared minus 2d minus 3 times y. Now this is the same thing because d stands for derivative, basically. So when you put multiply y times d squared, you'll get y primed, and so on. And that is going to still be equal to 2e to the x minus 10 sine x. And now we're going to need to solve for our homogeneous version. In doing that, we're going to take our the characteristic equation, which is then going to be equal to m squared minus 2m minus 3, which is equal to 0. Because we're saying it's homogeneous, therefore, for d squared minus 2d minus 3 times y, whole thing times y, is equal to 0. So since that is we change to say that's homogeneous, we can plug it in such as this. And then separating out the function, we get m minus 3, m plus 1 equals 0. Therefore, our m value is equal to 3 and negative 1. Putting into the fundamental solution of the homogeneous version, it is going to be equal to e to the 3x and e to the negative x. Now, therefore, our yc value is equal to c1 e to the 3x plus c2 e to the negative x. And now what we're going to need to do from here is find our GF and GD and FD. Now our FD we've already found. It is going to be this function right here, which is FD. And then for our G of D, we're actually going to find from this function. So we're going to go ahead and bring this one down here and say 2e to the x minus 10 sine x. We're going to find the annihilator of this function, which will give us d minus 1 times d squared plus 1, whole thing times y, is equal to 0. Therefore, that is our g of d value. So therefore, in order to find and solve for the non-homogeneous, we're going to take our FD, multiply it by G of D, which is going to equal D minus 1 times D squared plus 1 times D minus 3 times D plus 1, which is equal to 0. Now, you can solve for m by putting it into the characteristic equation and solving for it. M minus 1, m squared plus 1, m minus 3, m plus 1. Whole thing equal to 0. And therefore, our m is equal to 1 plus or minus I, negative 1, and 3. Therefore, we can say that our fundamental solution of the non-homogeneous version is going to be equal to e to the x, e to the negative x, e to the 3x, cosine x, and sine x. Now to find our yp value, we're actually going to need to take the fundamental solution of the non-homogeneous and subtract it with the fundamental solution of the homogeneous. Which, in doing that, we can say that the x to 3x is going to cancel, the x to the negative x is going to cancel, therefore it will leave us with the e to the x cosine x times and sine x. Now our yp, we can say, is going to be the general solution of that value. So we're going to say alpha e to the x plus beta cosine x plus gamma sine x. Now we can find the values for alpha, beta, and gamma. And to do that, we're going to start on a separate sheet of paper. So we're going to write down our yp value. So alpha e to the x plus beta cosine x plus gamma sine x. And to find alpha, beta, and gamma, what we're going to do is we're going to actually plug these back into the original differential equation. And in order to do that, we're going to need to take the derivative of yp 3 times, because looking at the original equation, the highest order is y double primed. So we're going to need to take the derivative twice. Therefore, we're going to say y prime of p is equal to alpha e to the x minus beta sine x plus gamma cosine x. And then therefore our y double prime of p is going to be alpha e to the x minus beta cosine x minus gamma sine x. Therefore, when plugging it back into the equation, you're going to get alpha e to the x minus beta cosine x minus gamma sine x minus 2 times whole thing of alpha e to the x minus beta sine x plus gamma cosine x minus 3 times the whole thing of alpha e to the x plus beta cosine x plus gamma sine x, which is equal to 2e to the x minus 10 sine x. Whew, that's a mouthful. Next, we're going to solve for our individual values. In doing that, we're going to find that our negative 4 alpha is equal to 2, which therefore we can say that alpha is equal to negative 2 over 4, and negative beta minus 2 gamma minus 3 beta is equal to 0. Therefore, since we know what our alpha is, we're going to plug that into the equation, giving us 2 beta plus 2 is equal to 0. Excuse me, 2 beta plus, that's a gamma, not an alpha. I'm sorry, we don't know what our gamma is yet. So we're going to leave it like that. And then the other equation we can get is negative gamma plus 2 beta minus 3 gamma is equal to negative 10 times, which can be rewritten to be 2 beta minus for gamma, which is equal to negative 10. Solving for alpha, beta, and gamma, we get alpha is equal to negative 1/2. Gamma is going to be equal to 2. And beta is going to be equal to negative 1. Therefore, our y of p is going to equal to negative 1/2 e to the x minus cosine x plus 2 sine x. Therefore, our general solution is going to be equal to y is equal to y of c plus y of p. Therefore, we can say y is equal to c1 e to the 3x plus c2 e to the negative x minus 1/2 e to the x minus cosine x plus 2 sine x. And that is the answer to homework 9, question number 6.